So before we proceed to the two-dimensional version of Gauss's divergence theorem, let's consider this example, number 4. Let's use the theorem to find the flux of the fluid with this velocity function, where your S is the top half of the sphere x squared plus y squared plus z squared equals 1. So sketch muna natin si S in 3 dimensions. This is your 3-dimensional space. Tapos from this equation, center of the sphere is 0. Tapos yung radius niya ay 1. So sphere centered at the origin, radius is 1. It's precisely this one, no? Now, according to the description of S, there is no mention na yung base netong hemisphere na to is included in S, no? So let's make that note. Yung base netong hemisphere na to, according to the problem, it is not included in S. And that poses a potential problem, no? Kasi itong divergence theorem that only applies kapag yung surface in consideration is a closed surface. In other words, dapat nag-enclose siya ng isang solid, no? And in this particular setting, dahil wala doon sa surface yung base natin, it doesn't enclose a solid, no? So how do you circumvent that? We will do the following. So let's let S naught be the base of the hemisphere. So yung S naught natin, yun yung base netong hemisphere na to, no? Itong part na to doon sa XY plane. And since itong base natin, nakapatong siya doon sa mismong XY plane, therefore it's part of the XY plane, dapat yung equation na tong S naught na to, as a surface, it is Z equals 0. Kasi remember, the XY plane, its equation is Z equals 0 eh. Okay, what else? Let's let S1 be the union of S naught and S. So, kapag dinrawing natin to again in 3 dimensions, your S naught is this one, itong circular base natin na to. And then your S is the hemisphere, itong black na surface na to, it's this one yung hemisphere. And the union of S and S naught will now give you a closed surface. So yung S1 natin, isa na siyang closed surface and therefore Gauss's divergence theorem that will now apply to S1. Pero take note, no? Yung goal natin is to find the flux over S. So ito yung hahanapan talaga natin ng flux, pero to determine that flux, dadaan muna tayo kay S1. Okay, let's set up integrals. Since yung S1 natin is just the union of S naught and S, and itong dalawang surfaces na to ay disjoint, when you compute for the flux over S1, what do you get? So you should get now the flux over S naught and then add it to the flux over S. Kasi remember, itong S naught and S, they're disjoint surfaces. To get the flux over the union, you just take the flux over the component surfaces and then add them. So yung flux over S1 is just the flux over S naught plus the flux over S. And then remember, no, ito yung goal natin, yung flux over S. So we isolate this on one side of this equation. So yung flux ni F over S, it is now the flux over S1, transpose yung flux over S naught. So you have now the flux over S1 minus the flux over S naught. So in other words, para makompute natin yung flux ni F over S, kailangan natin computein yung flux over S1 minus yung flux over S naught. So we compute for this and we also compute for this and then take their difference. Okay, let's start muna with S naught. And as you can recall, yung S naught natin, it's the base with Cartesian equation Z equals 0. So yung S naught natin as a surface, its Cartesian equation is Z equals some G of xy, no? Where in particular, itong G of xy natin, it's equal to 0. So kapag kinompute nyo, by definition, yung surface integral ng F over S naught, what's that equal to? It's now equal to the double integral over yung projection D onto the xy plane. We will describe that later. Tapos yung integrand natin is now f of xy. Tapos yung z, you replace that with g of xy, no? That's how the definition goes. And then this vector, you take its dot product with the vector negative g sub x, negative g sub y, and then 1. So inject na natin yung example natin dito sa definition natin. So remember, si g of xy in particular, it's equal to 0, no? So this vector here, this will become f of xy0. Itong vector na to. Tapos, yung g of xy natin, it's constantly equal to 0, no? Both of its partial derivatives, therefore, will be equal to 0. So, this is 0, this is 0. So, itong vector na to, this will become 0, 0, 1. Okay, and then let's now express this in vector form. So, yung z component nyo rito is 0. So, your z here is equal to 0. This is x times 0, you get 0 here. Tapos dito naman, you get tangent 0, that's 0. Plus y cubed over 3, you get again y cubed over 3. And then the third component is x squared times 0. That's again 0. Plus y squared, you get y squared. So itong vector na to, it's just equal to 0 times y cubed, not times, rather 0, comma y cubed over 3 comma y squared. That's the vector form here. And then you take the dot product of this vector with 0, 0, 1. Okay, let's dot these two vectors together. What do you get? You should get 0 times 0, that's 0. Y cubed over 3 times 0, you get again 0. Tapos y squared times 1, you get y squared. So ito yung magiging resulting integrand natin. And then when you simplify this further, you of course get the double integral of y squared over d. Now remember, ano nga ba yung d natin? It's the projection of S naught onto the xy plane, no? Pero remember yung S naught natin, di ba, it's the circular base. Yung sphere natin, di ba, it has radius 1, it's centered at the origin. So dapat, yung magiging d natin, yung projection, is a circular region of radius 1, centered at the origin. So circular region siya, it's centered at the origin, so it's convenient for us to convert this integral into polar coordinates. So kapag nag-polar form na tayo, what do we get? So yung integral na to, ng y squared dA, it's now the double integral of yung y in polar form, that is r sine theta, no? So when you square that, that will become r squared sine squared theta, no? That's your new integrand. And then your dA in polar, it's now r dr d theta. So remember sa polar, meron lagi tayong butaw na r, no? It's always like that, just as in the cylindrical case. Now remember yung d natin, it is the unit circle, no? Its radius is 1, its center is the origin. So kapag nag-dr tayo, like what we discussed in a previous example, yung starting limit natin for r is 0, and then your upper limit is 1. Remember when we did the example before, we started at the pole, tapos extend tayo hanggang makarating tayo dun sa circle of radius 1. Kaya yung start natin is 0, yung end natin is 1. And then for d theta, remember that's the full circle. So kung full circle, the limits are always from 0 to 2 pi. So this is now the iterated double integral that we have to consider. And how do you evaluate this integral? You consider first the innermost, no, with respect to r. So kung with respect to r tayo, yung sine squared theta, lalabas yan dun sa integral with respect to r. So you get now the integral of sine squared theta. And then now you have r squared times r, that's r cubed, no? So your resulting innermost integral is now the integral from 0 to 1 of r cubed times dr. And then when you integrate r cubed with respect to r, what do you get? You get now r to the 4 divided by 4. And then of course, you evaluate from r equals 0 papuntang r equals 1. Okay. Tapos when you evaluate this even further, what do you get? You get 1 to the 4th over 4. Of course, that's 1/4. Minus 0 to the 4 over 4, that's 0. 1/4 minus 0, of course, you just get 1/4. Tapos labas si 1/4 dun sa integral, no? You get this, so labas si 1/4. And then remember si sine squared theta by the half angle identities. It's equal to 1 minus cosine 2 theta, all divided by 2. So remember, isa itong integration technique from Math 22, no? Where you integrate even powers of sine. Yung ginagawa natin is we reduce the power by invoking half-angle identities. So, yun yung gagawin natin dito. Pero first, labas natin si 1/2. So, you have 1/4 times 1/2 sa labas. You get 1/8. And then, essentially, you're just left with the integral of 1 minus cosine 2 theta na lang, no? Now, with respect to theta, what's the antiderivative of 1? Of course, that's theta. And then minus, for cosine 2 theta, what do you do with that? You can let u be equal to 2 theta, no? So that yung magiging du ninyo is just 2 times d theta. Isolating d theta, you get du over 2. So this will be du over 2. Tapos ito magiging cosine u na lang, no? So yung magiging resulting integral ninyo is 1/2 times the integral of cosine u du. Pero what is the antiderivative of cosine of u? It is positive sine u, no? So you have 1/2 times sine u. You get 1/2 times sine theta, no? Or rather sine 2 theta, kasi your u is 2 theta. So you get here minus sine 2 theta over 2. Remember minus to, no? Kasi may minus kayo dyan. Tapos yung antiderivative nito will retain the sign of this. So, negative sine 2 theta over 2. So, if you're still a bit confused, yung pwede nyong gawin is, you can write down the substitution explicitly, no? Tapos work out all of the substitutions, integrate, you should get this one. Okay, and then for this, you now evaluate from 0 papuntang 2 pi. And then let's do the actual evaluation ngayon. You get now 1/8. And then times replacing theta with 2 pi, you get here 2 pi of course. Minus sine ng 2 times 2 pi, you get sine 4 pi, all divided by 2. So ito yung magiging evaluation at theta equals 2 pi, no? And then minus, when you evaluate everything at 0, what do you get? You get here 0 for theta. Minus ito magiging sine 0, no? Pero yung sine 0, di ba, that's 0. So 0 minus 0, you will still get 0. Now remember, yung sign ng kahit anong integer multiple ng pi, that will still give you 0, no? So itong second term natin na to, magiging 0 pa rin siya. So you get 2 pi minus 0, you still get 2 pi. So you get 2 pi over 8, or in other words, you should get pi over 4. So yung flux natin over S naught, it's now equal to pi over 4. That's taken care of. Okay, let's now consider the integral over S1, which is, if you recall, it's the hemisphere plus the base. And dito sa S1, recall, this is now a closed surface. So dito, pwede na tayong gumamit ng divergence theorem. So by the divergence theorem, yung flux over S1, it's now equal to the triple integral of the divergence over the enclosed solid G. If you recall, ano nga bang enclosed solid G natin? It is the hemisphere, no? Along with the base. So dahil spherical siya, yung pinaka-convenient na pwede natin gawin dito is to convert into spherical coordinates. Pero first, let's compute for the divergence of F. So by definition, ano yung divergence? It's the partial of the first with respect to x, plus the partial of the second with respect to y, plus the partial of the third with respect to z. And then when you compute for each of these partial derivatives, you can check. Itong first term magiging z squared. Ito naman yung tangent z0 yan, no, with respect to y. Tapos differentiating y cubed over 3, you should get y squared. And then for the third term, ito matatanggal kasi independent to of z. Ito naman, lalabas si x squared, derivative ng z is 1. 1 times x squared will give you x squared and then dv. Okay, and then like I mentioned, let's now convert this into spherical coordinates. So kapag nag-spherical coordinates tayo, itong triple integral na to, it's now the triple integral of what? Kasi z squared plus y squared plus x squared in spherical coordinates, this is equal to rho squared, no? Remember, x squared plus y squared plus z squared equals rho squared in spherical. Tapos si dv, in spherical form, it is now rho squared sine phi times d rho d theta d phi. So like with the cylindrical case, meron tayong butong na factor for spherical. This time, it's rho squared sine phi. And then all we have to do now is to determine yung limits for phi, or rather yung limits for rho, for theta, and then for phi. Now, how do we determine all of this? Balikan natin yung surface natin. So start muna tayo dun sa rho. How do you determine yung rho? Basically, yung gagawin nyo is yung katulad ng ginagawa natin sa polar, no? This time, you start at the pole, itong origin na to, and then extend onto the surface. Now, in this case, yung starting natin is, itong part na to, and itong pole na to, it's part of the surface itself. So, ano yung lower limit natin? It's precisely rho equals 0. Kasi yung spherical equation ng origin, it is rho equals 0. And then from the pole, you extend onto the surface until at some point makarating kayo dun sa hemispherical part, no? And if you remember, ano yung hemisphere natin? It is radius 1, no? And spheres of radius 1 centered at the origin, their spherical equation is rho equals 1. Kasi remember, in general, kapag meron kayong sphere centered at the origin of radius r, dapat yung magiging spherical equation niya is rho equals r. In particular, for this sphere, it's rho equals 1. So yung magiging limits natin for rho, they are now what? They are now from rho equals 0 papuntang rho equals 1. So that's for rho. And then for theta, what do? You now consider yung projection ng hemisphere onto the xy plane, no? Which is, as you recall, it's just the circular base. Tapos you do what you normally do dun sa paghanap ng limits ng theta for polar, no? So for theta in this case, kasi again full circle centered at the origin, the limits for theta are from 0 papuntang 2 pi ulit. And then yung phi yung magiging problema natin ngayon. So again, let's return to the surface. So yung phi natin, or rather yung surface natin, it's this one, no? To get the limits for phi, this is what I normally do. So I start at the z-axis. So ito yung z-axis natin. Tapos yung gagawin natin is, I consider a line from the z-axis, you rotate that until you get to the positive y-axis. In this case, yung unang tatamaan, yung angle that it forms with the z-axis, yun yung magiging lower limit nyo for phi. Tapos you rotate. Tapos yung huling matatamaan ng line na yun, yung rotation nun, yung angle that it again forms with the z-axis, that will be your upper limit for z. Now for this particular example, di ba, we started at the z-axis. And since yung mismong z-axis is part of this surface, yung angle that the z-axis that forms with itself, of course, that is phi equals 0. So yung lower limit natin for phi is phi equals 0. Tapos from the z-axis, you rotate until you get to yung pinakadulong part ng surface natin, no? In this case, yung pinakadulo is this part. Tama ba? And in this case, yung angle that this one forms with the z-axis is what? It is 90 degrees, no? Or in other words, yung magiging upper limit natin is now phi equals pi over 2. So yung limits natin for phi, they are now what? They are now from 0 papuntang pi over 2. So this is now the triple iterated integral that we will work with. So when you simplify, you should get rho to the fourth times sine phi. Yun yung magiging bagong integrand natin. And again, I won't show the solution further. You can verify na yung magiging triple integral na to is now 2 pi over 5. So again, just do the necessary integrations. Yung pinaka-important na part dito is how to be able to set up the proper integral here. Okay, so we now have the integral over S1. It's equal to 2 pi over 5. So meron na tayo for S1. We now have the integral for S0. We can now set up the flux, which is the surface integral over S. And this flux, if you recall, it's now equal to the integral over S1 minus the integral over S0. Yung S1, it's 2 pi over 5, no? Tapos yung S0, na-compute natin yun kanina to be pi over 4. So 2 pi over 5 minus pi over 4, their difference is now 3 pi over 20. So the flux, it's now 3 pi over 20. Okay, let's now proceed to an analog of Gauss's divergence theorem in 2 dimensions. We will do 2 examples of this, pero let's first recall that statement. So ano yung kailangan natin sa R2? So kung R2 tayo, what we need is now a simple closed curve C, which is positively oriented. Tapos what else? So kung simple and closed curve yan, yung mangyayari niyan is that will enclose a region, no? We will call that region D. So let's let D be the region in R2 enclosed by this simple closed curve C. Tapos of course, apart from these two, we need a vector field of 2 variables, P and Q, which is, again, like with the assumptions before, itong P and Q na to, they must have continuous first-order partial derivatives. Okay, then what does Gauss's divergence theorem in R2 state? It states na yung line integral ng F over C, it's now equal to this time kung kanina triple integral tayo. Ngayon, in this case, it's now equal to the double integral of the divergence over this enclosed region D. So essentially, it's an analog, no? Imbis na surface integral, line integral yung kukumputin natin. And imbis na triple integral, we now have a double integral. And like what I mentioned before, medyo mahirap computing yung parametrization ng C in the long run, no? So instead of considering this C, we consider yung region bounded by C. Okay, and again, in this case, yung N natin, it denotes the unit normal vector of C. Okay, let's proceed with 2 examples here. Let's determine the flux of the fluid with this velocity function, where your curve C is just the parallelogram with these 4 vertices. Okay, so let's sketch that parallelogram in 2 dimensions. So yung relevant na vertices ay 0, 0, ito. Tapos 4, 0, this point here. Tapos 1, 3, and then 5, 3. So that kapag tinrace nyo na yung parallelogram, it should look like this. So ito yung magiging parallelogram natin. This is your curve C. And then let's set up now the necessary integral. By Gauss's divergence theorem, that flux over there, which is the line integral of F over C, that's now equal to the double integral of the divergence of F over this enclosed parallelogram region. So ito yung D natin, yung loob ng parallelogram. And then when you now compute for the divergence of F in 2 dimensions, what is that? It's now the partial of the first with respect to X plus the partial of the second with respect to Y, and then dA. Tapos when you compute for partial derivatives, yung derivative ng x squared with respect to x is 2x. Ito mag-zero out with respect to x, so okay na to. And then plus itong 2xy with respect to y, diba that's just 2x. And then itong 4y magiging 4 na lang. So you have 2x plus 4, or in other words, you get 4x plus 4. So ito yung magiging double integral natin ngayon. And as you can see here, itong curve natin, or rather yung region D natin, it is rectangle, or it is a parallelogram, no? So it would be helpful to retain this in rectangular coordinates. Okay, let's now compute for the iterated integral here. So your integrand is still 4x plus 4. Now as you can see here, mas madaling mag-determine ng mga rightmost curve and leftmost curve, no? As opposed to when you have to determine lower curves and upper curves. Kasi yung mangyayari is kapag nag-integrate tayo first with respect to y, anong mangyayari? You have to split the region, no? Kasi yung mangyayari dito is from here to here, yung upper part ng region natin is this line over here. Tapos from this point until this point, mag-iiba yung upper part ng ating region, no? It's now this one. Tapos from this point to this point, ito naman yung lower part ng region natin. So it's less convenient for us to start with y. So instead, let's start with x. So when we start integrating with respect to x, we have to identify yung leftmost curve ng region natin and yung rightmost curve ng region natin, no? Now in this case, what is the leftmost curve of this region? In particular, it's this one, no? This will be your lower limit. So para ma-determine natin exactly itong lower limit na to, we need to determine the equation of this line. And you can check yung equation nitong line na to from 0, 0 to 1, 3. It's just y equals, yung y-intercept is 0. So 0 yung constant. And then the slope must be 3. You can verify that. So the line here is y equals 3x. Pero take note, since we're integrating with respect to x, you have to isolate x in this equation, no? So yung magiging upper limit natin is now x equals y over 3. So yung lower limit natin dito is y over 3. So that takes care of the lower limit. And then from this point, you move to the right until you get to this point. This will now be your upper limit with respect to x. Tapos ano mangyayari ngayon? We now have to determine the equation of the line from 4, 0 to 5, 3. And same thing, no? Yung dito yung mangyayari dito is yung y-intercept natin is negative 12. You can check that. And the slope is still 3, no? Kasi these two line segments are parallel. So you have your equation to be y equals 3x minus 12. Tapos kapag in-isolate nyo si x in this equation, you should get x equals y plus 12 all over 3. Yun yung upper limit natin. It's now y plus 12 over 3. Okay na yung limits natin for x, no? To get now the limits for y, what do? You now make this red horizontal line move from the bottom upwards, no? Tapos kapag nag-move kayo from the bottom upwards, you have to start at this one. Pero remember, this horizontal line, this is the x-axis. Its equation is y equals 0. So yung lower limit natin for y, and then you move upwards until you get to this line here. Ano yung magiging equation niya? This is now y equals 3. Kasi the y coordinates are 3, eh. So yun yung magiging upper limit natin. Should be 3, okay? So magiging from 0 to 3 yung ating dy. So just verify this is 3, okay? And then I won't again evaluate this integral any further. This should be equal to 168. So again, just take note of this error. 3 dapat to, okay? Okay, for our last example for the day, let's determine the flux of the fluid with this velocity function. And your boundary region C, and your curve C is the boundary of the region enclosed by these two circles. So itong circle na to of radius 1 and this circle of radius 3. Okay, let's first sketch that curve C in 2 dimensions. So yung unit circle natin of radius 1 centered at the origin, it's this one, itong part na yon. Tapos yung radius 3 naman, it is this one. Tapos yung magiging enclosure nila, it is this one, no? This region here shaded in gray. So itong dalawang circles na to, they will constitute your curve C. Tapos yung magiging region enclosed by these, ito yung magiging gray region natin dito. Okay, so let's now set up the integral by Gauss's divergence theorem, the flux, which is the line integral over C. It is now equal to the double integral of the divergence over the region D enclosed by C. Okay, and then by definition again, yung divergence natin is just the partial of the first component with respect to x, plus the partial of the second component with respect to y. And then you can use the quotient rule, no, to determine the derivative of both of these functions over here. And you can check na yung magiging derivative dito is y squared divided by x squared plus y squared all raised to the power 3 halves. Tapos ito, imbis na y squared, magiging x squared ngayon yung magiging numerator na to. So this is now the partial with respect to x. Ito yung partial with respect to y. And then when you add them together, you should get the numerator of x squared plus y squared. And then let's simplify this one. This will simplify to 1 all over the square root of x squared plus y squared. Kasi ito, when you bring that to the denominator, this will become x squared plus y squared to the negative 1. You get 3 halves plus negative 1, that will give you 1 half. And then in radical form, you should get this. And then remember yung D natin, it consists of circles, no? Of 2 concentric circles. So again, it would be helpful for us to convert this into polar coordinates. So kapag nag-polar tayo, what will happen to that? Itong x squared plus y squared na to sa baba, this will become r squared, no? And the square root of r squared, that's just r. So this one in polar form is 1 over r. And again, dv, that will become r dr d theta. And then yung dr, remember what did we start with? In this case, ito yung pole, no? You extend a radial line, tapos yung una yung tatamaan is this circle, no? Of radius 1. So you start with r equals 1. And then you extend further until you get to this circle of radius 3. Therefore, yung magiging upper limit natin is r equals 3. So yung lower limit natin for r is 1, and then the upper limit is 3. Tapos for theta, again, we're considering the entire circle, no? Full revolution tayo. So again, theta is from 0 papuntang 2 pi. And then when you simplify the integrand even further, you should get this one. So what you get all in all, you should get, itong integral na to is just 3 minus 1, no? Tapos itong integral na to is from 0 to 2 pi, it's just 2 pi. So you get 2 pi times 3 minus 1, you get 2 pi times 2, or in other words, yung flux natin is now 2 pi, or rather 4 pi. Okay, so that's it for today's session. So again, I suggest you answer the exercises in the module para ma-practice kayo. That's it for today. Thank you all for watching.